We just want to thank you all for taking the time out of your busy schedules to come to our workshop. This presentation that we're going to show you, just in case you enjoy it so much and you want to see it again, we do have it on each of our websites. So it is there for you to go back and do a refresher if you just really love the presentation, which I know. So welcome. This is just kind of where we're headed through the presentation. We're going to touch on each of these things. We're going to touch on a little bit of the language, talk about part, whole, model drawing, making a 10, branching, and then we're going to open it up to questions at the end. So just so you kind of have a goal as to where we're going. Okay, the language of Singapore math. Some of the terms that they use in Singapore math are different from how we all learn, so we kind of wanted to go through each of those just to be more clear. At the beginning of the year, we talk a lot about digits. Those are the numbers. We show them the number word, we show them the digit, and then we show them kind of a pictorial representation of that number. At the beginning of the year, we really focus on the equal sign, and most of us say equals, but in Singapore math, they kind of like us to say is the same as. Both are correct, both are fine, but that's kind of the term that they use. And we all got out our balances to kind of show them. You know, we put 5 blocks and 2 blocks on one side, and then we put 7 blocks on the other. And we're saying 5 and 2 are the same as 7. So that's one of the terms. Equation we use a lot. Number sentence, you know, same thing. Number bonds, which we're going to talk about more in a minute. And that goes along with whole and part. Greater than, less than, unifiers, which I will touch on when we do model drawing. Those are kind of like the little squares that they use to represent things in a word problem. And then branching, Lindsay's going to touch on, and to be honest, I think that's the hardest part of first grade math is branching. Just because it's so different than how we all learned, and I know when we were learning Singapore math, it was the hardest for all of us. And then concrete, pictorial, abstract, that's kind of the way that children learn. And that's how we try to teach. You know, we start with the concrete. We're using manipulatives. And then we move away from the concrete to the pictorial. So in their workbooks, they're going to see picture representations. And then hopefully they'll get to the abstract, which is the equation or the number sentence.
The part, whole, you guys all had the number bond cards that came home towards the beginning of the year. We had the addition and then the subtraction. We work on them in class as well, just where you see that you have the 2 parts and they make up the whole. So it's just, you know, the 2 parts, you put them together. So if you'll turn in your packets, on that first page, you'll see some number bonds. And so you see the top one, you have 3 and 5, and then the whole is the one that's off to the side by itself. And so they would have to add the 3 and the 5 together, and your answer, your whole would be 3 plus 5 equals 8, or 3 and 5 is the same as 8. Okay, and then underneath it, they give you the whole, which is 8, and then they give you one of the parts. So for this, you could say, some of the kids look at it as, well, I know 3 and 5 make 8, or you could do the subtraction part of it, 8 minus the 3 they've already given you equals the 5 that's left over. And so we work with the number bonds and the part, whole as part of the fact families. So if this is your number bond, then 5, 3, and 8 are the numbers in your fact family. And we kind of talk about how, you know, we have cousins and aunts and uncles, but the people in your family, that's who you stick with. That's your fact family. So anytime you're writing the addition or subtraction facts for it, for this one you could do 5 plus 3 equals 8, or the turnaround fact, which is 3 plus 5 equals 8. Then your subtraction would be 8 minus 3 equals 5, or 8 minus 5 equals 3. And so when you're writing the facts for the fact family, those are the only 3 numbers you should see. Yes, 8 plus 3 equals 11, but that's not part of this number bond. That's not part of that family. So the goal is that once they get all of these part, and wholes, which are basically their math facts, then the equations just come naturally to them because they learn, oh wait, well if I know this number bond, I know all 4 of those facts already. So just practicing with the number bonds, you know, like I said, we have them in class and we practice with them. You guys have the ones at home. You know, I know during conferences we kind of talked about things, and don't feel like you need to overwhelm them with all of those cards every single night. You know, just practicing a few at a time will just help them in their fluency so that they don't even have to stop and think. They don't have to get to the pictorial or the concrete, they just know them. You can do it through flashcards, you can do it through the number bond cards, there's websites, games, there's tons of different ways for your child to practice that, and half the times they don't even know that they're actually practicing and learning because you can find websites or games to go with it. So that's part of that part whole. And this will go into branching as well. If they know those facts, then that's going to help them with the branching part.
Okay, model drawing. It's just another word for word problems or problem solving. And the way we do it is it's like a visual representation of it. We're very deliberate in the way that we introduce it to them. It's kind of a step-by-step process. So for instance, the first step is we read the problem together as a class. Then we identify the who and the what. So for instance, in this problem, Mary and Joe are the who's, the what is carrots. And the step-by-step process is something they will use in first grade and second grade all the way through. And we all try to kind of be consistent with that. After we do that, these are the little unit bars that I was talking about before. I know at conferences, we kind of went through this quickly. This is their model drawing book. It's actually written not from Singapore Math, it's actually from a different company, SCE, but it goes along perfectly with our program. It's great the way they do it. They start off with pictures, and then they move, I'll move a little closer, they move the pictures into the unit bars, just like we have up there. And then they take the pictures away, so they just have the unit bars. And then the students are in charge of drawing the unit bars. This is the hardest thing for them. Just drawing all those little squares takes a lot and a lot of practice, but they're doing a really great job with it. So after they draw the unit bars, 6 unit bars for Mary, 4 for Joe, then they have to write the digit next to it. And then this little thing here, this is what we call a bracket. And in this case, this is an addition problem, so we have to draw the bracket to show how many in all, and we really focus on those kinds of words too. In all together, how many are left, those are your clue words to figure out what you're doing. And then they can solve the problem. They can say, okay, well this is a good one because we know 6 and 4 makes 10, that's one they should know. But if they don't know, they can count the unit bars, and they write their answer there at the end of the bracket. And then the last 2 steps are to write the number sentence or the equation. And then they always end by writing a written sentence that goes along with it. So what we've done is, if you'll turn in your packet, we have 2 examples. So we're going to play school. So you get to be the boys and the girls in the class. And we're going to do this, we'll do this just like how we would do it in class. Okay, boys and girls, we're going to go ahead and read the first problem, starting with the word Michael. Ready? Begin.
Michael shot 4 baskets. Nick shot 5 baskets. How many baskets did the boy shoot in all?
Wow, great reading. Use your brains. All right. So first we would say, okay, who are our who's?
Nick.
Michael and Nick. What is our what? Baskets. Okay. All right. How many baskets did Michael shoot? 4. So then they would go ahead, if the unit bars weren't here, they would go ahead and draw the 4. How many baskets did Nick shoot? 5. And then we tell them to go ahead and write the digits next to their unit bars. And then we kind of go through it. Okay, what do we do next? We draw the brackets. So then they would go ahead. And in all of our classrooms, this is exactly how we do it. We have it projected up on the screen. And what's really fun is last year we did this thing where we let the students be the teacher once they got a really good hang of it. And they loved that. They would come up and they would ask all the questions, you know, that we normally do. No, this is an example. We have the boxes, we have the unit bars drawn, but now we're at the point where it's just plain and they have to draw.
Yeah. But they're not drawing pictures in it, if that's
Correct.
No, they're
That's how
just
they
the
start.
boxes. It starts with pictures just to help them.
And they're really good. Like they understand. Like if I need 4, they know to make 3 lines. So that in the beginning, they're why am I only making 3 lines? But you know they draw their unit bar, and we talk about lining them up. That's really important that they start at the same starting point. And then when they make their unit bars, this one's going to be a little bit longer because there's more. So, and then they draw 3 lines and then 4 lines for that one to make 5. But they're getting, I mean, they're doing great with that. They're doing awesome. Sorry, guys.
No, you're good. And then, like I said, then we solve the problem so we can count. Okay, we're at 4. Let's count on. We're practicing counting on. So we're at 4, 5, 6, 7, 8, 9. So then they write, they actually put a question mark there because that's what we're trying to find out. And then you can go ahead and write the answer and we circle it just to kind of show that's what we were trying to figure out. And then the next step is to write the equation, the number sentence. So they would help us do that. 4 plus 5 is the same as 9. And then they fill in a sentence. They shot 9 baskets in all. Okay, so that's kind of how we did addition. And then we moved on to subtraction. And we try to do it so that it coincides with what we're teaching in the classroom. So when we moved on to subtraction, then we started doing subtraction while drawing. So let's go ahead and do this one. Now you'll see this one's a little bit different. So let's read the problem. Ready? Go. Tom has 12 seashells in his bucket. Then 7 shells fell out. How many are left? And we highlight, you know, like I said, are left. Okay, what are we doing? We're subtracting. So in subtraction, like Kate said, we start with the whole. So what we ask them, you know, after we have the who and the what, we say, what is the whole? Okay, 12, that's how many we started with. So we're going to draw 12 unit bars, okay, because we already know how many we started with. Then 7 of them fell out. So to represent that, what we do is we cross out 7. And we teach them to do it from the right, which some of them ask, why are we doing it over there? Because, you know, everything else we do, we start left to right. But it's kind of to show that they kind of fell off the end. Like this was the end and it fell off the end. So once they've crossed off their 7, we draw the bracket above those 7. And we write 7 to represent that.
And we teach them to cross it diagonally because you'll find if they try to do it up and down, all that's doing is making more unit bars.
Right. Yeah.
And that really throws them.
And then we teach them to draw the bracket over the ones that are remaining. Draw your question mark, because that's what we're trying to find out. We're trying to find out the missing part, how many are left. Yep. And you'll see too, like if at the beginning of the year, a lot of us, what we'll do is we'll have them draw the unit bar, or the number bond that goes along with the problem. Just to kind of show them that these all connect. You know, the number bond and the equation and, you know, the picture, they all go together. Okay, and then we can easily just count the unit bars that are left. There's 5 left, so we write that and circle it. And then they write the equation, 12 minus 7 is the same as 5, and then the sentence below. Later in the year, when we start multiplication, the very end of the year, and basically we just teach them that it's repeated addition. It's kind of just a glimpse at it, just to get them ready for 2nd grade, nothing to stress or worry about. But what's great is in our model drawing books, they have a section on multiplication. It's just really short at the end. And again, they show it as repeated addition. So it's, you know, 5, 5, 5 would be 5 times 3 equals 15. So it works really well with our program.
All right.
Right, the next thing we're going to talk about is,
In the Singapore math, everything is based on 10, and it's like the golden number to either get to 10 or to pull out your 10. And I've heard a lot of parents that have said, oh yeah, well, I kind of do that in my head too. What you're trying to do is, ultimately this goal is to get the kids to get better at their mental math. And when you're doing that, a lot of times, if you think about it, you'll think, well, how can I get it to 10 and go on from there? Because it's so much easier to add things to 10s than it is to add a bunch of little ones together. So it's a base 10 system. We work a lot with the pairs that equal 10. Sometimes we call them 10's friends. So, you know, if I say 2, you would say 8. Okay? If I say 7, you would say 3. And we have 10's frames that we work with in our calendar every day. We have cards that are the 10's frames where we could hold this up and they would see that this is 9, we're missing 1. So 9 and 1 are the pairs. You'll see when Lindsay talks about branching that we're either pulling 10 out or putting them together to make 10. So if they can get down their 10's friends, the pairs that make 10, that is something that's very important and will help them in the future. Yes, we still want to work with the other number bonds and their math facts because those come into play obviously all the time, but the 10s are very, very important. So we're working a lot with those, almost to where it's just second nature to them. You can sit there and just say 2 and 5 and 4 and they know it automatically. We're also starting with the 11 to 20 range, just working towards the next 10 and getting them to kind of understand, well, if you know that 3 and 7 is 10, then once you hit 13, 7 is going to take you to 20. And so then they kind of see that correlation and they can move up from any 10s at that point. So just making the 10s and working with those and helping them to see, well, if I know that 7 and 3 make 10, then when you ask me what is 10 minus 7, I've already got that in there. I already know that that's the 3. And so just kind of getting them to see how it all intertwines and connects. Okay, perfect. Thank you.
Okay, we're going to talk a little bit about branching. This is a mental math strategy that we teach them. This is a strategy, and it's really trying to get them to eventually do this in their head, which a lot of us already do. We say, oh, you know, I make it easier by making a 10 or pulling 10 out and then adding the leftovers. We're going to go through a couple together. We're going to show you some of the different strategies that we've already showed them in class. They've been working on it during this whole month, and it will come back. So we've taken a lot of time to really go over this. They can still use their number line. That's a great tool for them to use. This is just, like I said, a strategy to try to get them to start thinking about math mentally in their head, and it will help them as they go through each grade level. But it's going to come back. So we're just going to go over a couple of different problems. The first one, 9 plus 7. So we see that number, 9 plus 7. We see that number sentence. And I'm going to say I have the number 9. It's really close to the number 10. So how close is it to the number 10? How many more do I need to get to 10 if I have 9? How many more? 1. I need 1. So I'm going to pull out of 7, I'm going to pull a 1. And my leftover is 6. So that's kind of a number bond there. So you can see we talk about, okay, this looks like a number bond. So I would pull 1 out, and we talk about circling their 10. The 9 and the 1 is a 10. We call it the blob. So we put inside the blob the 10. 10 is a great number. Yes, it's a technical term. 10 is a great number. It's our favorite number in first grade. So we make our 10, and then we add on the 6. 10 and 6 is 16. So it's getting them you say, well, you'll look at 9 plus 7 and say, why did they have to go through all of that just to get the answer 16? Why did they have to branch? But eventually you can see that they could do this in their head. They could say, okay, I have 9, I need 1 more, I take the 1 away, and then I add the leftovers. So that's kind of what we're getting them, trying to get them to do mentally. When we start this, we talk a lot about, like Kristen said, the concrete, the pictorial, and the abstract. We use these a lot to start out with. We build the numbers, we pull them apart, we branch the numbers, and then we move on to their workbook and textbooks, which do have a lot of pictures, and it shows them how to pull the numbers, how to branch the numbers, and then we go into the actual writing it on their whiteboards, equations, those kind of things. So this is one example of one problem. Here's another example, and there's some in your packet that we're going to do in just a minute. 13 minus 6, so this would be a subtraction problem. So we would pull, we talked about making 10s and then pulling 10s out. We would pull 10 and 3 out of 13. And I kind of, the subtraction is a little tricky for them because we end up adding on the leftovers. So I use my pockets, and I talk a lot about 13. I'm going to put 10 in one pocket and 3 in the other. So this is kind of my visual for those who need a little visual. 10 and 13. Okay? So I need to subtract 6. Can I take 6 away from my pocket with 3? I don't have enough, so I have to go to my pocket with 10. So I'm going to take 6 out of that pocket. Okay, so I've taken my 6 out. Done. Now I have 4 left in that pocket, and then I still have my 3 left over. So I need to put them together. So it helps them a little to see it that way, because if I'm branching 13 into 10 and 3, okay, I take 10 minus 6, which we have them write it out for right now to see. 10 minus 6, and then we add the leftover 3. So 10 minus 6 would be 4, and then 4 plus 3 would be 7. Now that's a lot of steps, I know you're thinking, but like I said, as we go through, they will start to we're hoping, our goal is to get them to do it mentally in their head.
Yeah.
So we're going to try to,
I was just going to say, and it's important, we always teach them to put the 10 on this side, because if they do draw the blob here, so that they see, because otherwise if they put it over here, then they're trying to kind of draw it around the 3, so it just makes it easier for them. But like Lindsay said, the goal is that will be done in their head.
And like I said, we use these, they pull 13 out, and we talk about separating the 10s and the 1s, and then taking away from the 10 instead of the 3. So let's flip to your packet. We're going to do a couple together. You can use the manipulatives if you want, just to kind of see, or you can just follow along with me up here. We're going to look at the first one. We're going to do the first one together. The first two are kind of using the same strategy. It's adding. So I'm going to do the first one with you, and then I'm going to have you guys do the second one on your own to kind of get a feel for what we're doing. Okay, so thank you. 7 plus 8. And the kids know that sometimes they'll branch 8, sometimes they'll branch 7, and they've kind of come to know, oh, I can do it both ways. Can I show both ways on my whiteboard? Sure. But I'm going to branch 7 just because 8 is closer to 10. So I only need 2 more to get to 10. And I know 10 is my favorite number, so I'm going to make, I'm going to take 2 out of the 7. If I were doing this with pictures, I would maybe do 1, 2, 3, 4, 5, 6, 7. Okay, and then I might have 8 stars over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I know I have 2, so I'm just showing you what you might see in their workbook. I'm going to take 2 stars and put it over here. That's my 2. So for those who need a visual. And I have how many left over? I have 5. Okay, so there's kind of my number bond. I branched it out. I'm going to make a blob, our technical term here. 8 and 2 is 10. Okay, so, and they can write 10. I'm adding on the 5 plus 5 would be 15. Okay, and some of them might branch the 8 into 3 and 5. Circle the 10, add your 5.
And we worked a lot in mental math, just like Lindsay was saying, like 10 and 5 makes 15, 10 and 3 makes 13, 10 and 1 makes 11. So these are things that they should start to know. I mean, we do it in line, anytime. So that's stuff you can do like in the car, anytime. Just a quick thing to get their minds going. And that way it'll be much easier when we do this.
Yeah. so if I did 7 plus 8. Okay. So your question is, why wouldn't I break it down into 4 and 3? I pulled 2 out because I looked at my number 8, and I want to make it really friendly. I want to make it so simple for me to add. So I want to make that a 10. So how many more? If I have 8 and I want to make it 10, how many more do I need to make it 10? So I pull out a 2 for my 7, because now it's so simple for me to add 5 more on to my 10. So if I did 3 and 4, it would be 11 and 4. And we're trying, the Singapore Math is a really base 10 curriculum, so we're trying to get them to make a 10, make a 10, make a 10. And then that really comes into play later on with place value. When they get into, you know, 2nd grade and on up, they really talk about the place value. And they'll do this with hundreds, numbers in the hundreds in 2nd grade. So this is kind of just giving them a good foundation of making a 10, and then eventually making hundreds, making, you know, in 2nd grade they do a lot more of the mental math.
And they, like she said, practicing the 10 and 3 is 13. I mean, even today we were doing them, and there was a 10 plus something, and half my class was like, oh, this is going to be easy. Because they just know that adding anything to that 10 is a piece of cake, because they're basically just sliding it up into the ones place.
And you could branch to 8 instead of branching to 7. It's whichever you want to do.
Right, 7 plus 8. So if I want to make 7 and 10, I would do 3 and then 5. So there's my number bond. There's my blob, 10 plus, it's still 10 plus 5. But it's just pulling, and that's what I was saying. They could, some of them are like, oh, there's 2 ways to branch. You guys are so smart. You're right. There's 2 ways to branch. You could do it either way. But I just chose 8 because it was closer to 10. Let's, yeah, exactly. But they see it both ways, which is great. So the next one, 9 plus 5, I want you guys to try that one on your own. I'm going to walk around and give you a minute for some think time. Fire brand. Any questions on this one, and then we're going to move on. Any questions on this one? Okay, awesome. You guys are so smart. Push your brain. All right, moving on. Okay, 12 plus 6. This one, we would break down the 12. Like I said, we make a 10, and then we branch taking 10 out. So we practice, like Kristen said, like Kate said a lot, making 10s, pulling out 10s. 13 is 10 and 3, 15 is 10 and 5. They know that, just like we did 10 and 5 is 15. It's kind of the reverse here. So they would do 10 and 2. 10 and 2 is 12. And then I don't make a blob here, and some of them are like, why do we make the blob? I think they just really like to make it. But 2, I would just say, look at your ones. 2 plus 6, that's, again, knowing your facts, practicing those number bonds. 2 plus 6 would be 8, so I would have them, we would have them write the 8 and add on the 10 would be 18. Okay, so that's really almost like in 2nd grade when they get to a different kind of mental math strategy, going left to right, just adding the 1s, adding the 10s. So that's really all I would do for that one. Okay? All right. Subtraction. Okay. Subtraction, like I said, is a little different because I like to use my pockets a lot because it is adding back on. So I'm going to show you this one, and then you're going to do the bottom one on your own. So you can follow along with me on this one, and then let you try it out on your own. Okay, so 14 minus 7, and I will say we show these horizontally, but we've also shown, like with the addition one I just did, the 12 plus 6, we have shown them vertically as well. So we have shown them up and down just because they're going to see that. And so we want to get them used to seeing both ways. I forgot to mention that before. Okay, so 14 minus 7. I'm going to branch the 14 and to 10 and 4. Okay, and I put my 10 close to the 7 because remember I have my pockets. I have 10 and 4. 10 in one pocket, 4 in the other. I need to take 7 away. I can't take 7 from my 4. I don't have enough, so I need to go to the one that has 10. I should know that really quickly. 10 minus 7 is 3. So I'm going to write that out. 10 minus 7 equals 3. And sometimes I tell them, hold that 3 in your head. Okay, so you have 3 in one pocket. Hold that 3 in your head. And then I need to add my leftovers. Still got that other pocket just hanging out there. So I have 3 plus 4. And that would be my answer. My answer would be 7.
That's the hardest part for them because they're thinking, why am I adding when we're subtracting?
Yeah.
But like Lindsay said, when we use those kind of pockets like that and say, you know, you're having to put those two back together. You're having to take this pocket with this pocket.
Or if I did 1, 2, 3, 4, 5, I'm just using stars, they're quick. Here's my 10 and 4. Like this would be a picture. Sorry, they're not perfect, but that's okay. Just take your time. 10 and 4, that's my 14, and this would be something we would have them use these for. So I would take out 10 and 4, there's my 14, that's my whole number. I need to take 7 away. Okay, so I'm going to take 7 out. Well, I can't take 7 from over here, so I'm going to take 7 away from here. 1, 2, 3, 4, 5, 6, 7, and then there's my leftovers that I add. 3 and 4 is 7. So that's like the pictorial part. This is more the abstract, and this would be more concrete. So that's, like I said, with subtraction, it is kind of different, adding it back on. But if we show it to them like that, we use our pockets and we use our manipulatives, it's going to come. So why don't you try 15 minus 8 on your own by using branching. 15 minus 8. Can I have a volunteer to help me branch this one? 15 minus 8. Anybody? What do I do first? Okay, so I'm going to break apart 15 into my 10s and 1s, 5 and 10. Okay. Now what am I going to subtract? 10 minus 8. All right, because I can't. I don't have enough in my other pocket. 10 minus 8 equals 2. And then add the leftovers. Very good. 2 plus 5 is the same as 7. And so there's my answer. Awesome. Very well done. Okay.
And someone had a question over here. Just if they know 15 minus 8, can they just, can they write it down? Absolutely. We talk all the time about problems have different ways of being solved. If you know your facts, that is great. If you want to use branching, that's great. If you need to use your counters in your desk, that's great. If you want to use your number line, that's great. We want them to be able to know that there's different ways to solve a problem.
It's not like where this is the one said way. I mean, we teach a bunch and they're comfortable with different things, and I know it's usually just as long as you can explain it, as long as you understand how you got it, you can tell me how you got it. I mean, whatever, every child's different, so.
We always make a big deal about that. I was thinking about that with the 9 plus 5. I've had students say, oh, well, 1 more than 9 is 10. If I add 1 to that and take 1 off of the 5, 10 and 4 is 14. That's great. We make a big deal about that. They call it compensation in 2nd grade, and that's a mental math strategy that they're going to learn in 2nd grade. So,
And the other thing that we were just talking about is, I know for us, because we just learned to memorize it, we're thinking, oh my goodness, there's all these extra steps. You're going through so much. But for them, and it is, a little overwhelming at first because they're 1st graders. But like we said, they'll get it this year. They'll get it again next year. For them, they're kind of like a clean slate. So when they're learning it this way, it's not as, what in the world am I doing, as it is to you and I, because they don't know the ways we do. So the goal is that it helps them so much to be able to sit there mentally. I mean, we can sit on the carpet with them, nothing in their hands, and they can do so much of the mental math just because they've learned to make those 10s, they've learned to pull them out. I mean, you'd be amazed to hear and see what they can do without any kind of help or manipulatives, just because of the things that we've already been practicing. So I know it's kind of crazy to us, but to them they're kind of fresh. Yeah.
As far as the Singapore math philosophy, is there any grade where the idea that they can use any strategy, does that change in any particular grade where they now have to hone it down to using just one strategy? Or we should kind of begin to discourage that as time goes on, or will they always kind of be allowed to do it how they do it as long as they can defend it?
I mean, in 2nd grade, I know that they teach a whole span of mental math strategy. I mean, there's a whole unit on mental math strategies, compensation, all these different strategies, and it's really interesting to see the different ways that they come up with it in their head, and we celebrate that. I mean, we
all the
want
way
them
through.
all the way through.
But actually, by the time they get to 6th grade, for example, I mean, math is math pretty much, and they have the strategies, or, you know, perhaps they haven't learned those yet. So the teachers try to embed some of the strategies, but really, I would say many of them are learned in 1st, 2nd, and 3rd. So does that answer your question?
Yes.
What the big shift for all of us as educators was, there are lots of ways to solve the problem. And another thing is, I think in the past we've done a lot of the talking and the explaining. And what these ladies are so good at is asking questions. Well, how did you solve that? Well, did you solve it that way? Or tell me how somebody else solved it. So they really do learn to not just do math, but to think and not just memorize.
And they're teaching their friends too. Like, you know, my friend Jacob might have a really great way of solving it. Hey, guess what I did? And it's awesome. And then somebody else, oh, I did it that way. Or, you know, and they learn from each other. I think that's the best. You know, when they can explain it, you know, one-on-one in their own terms.